Today, I, Hazelle de Cruz of Ateneo de Manila University from the Philippines, present to you the work of PhD student Abigail Isaacson, postdoc Stevens Vayoklo, and advisor Dr. Che Cunnan from Newcastle University in UK, who made news this May for being the first to 3D print a human cornea, which won them gold in the DrivenX Design Now Awards. This is their response to the high shortage of corneas for millions of transplant patients on queue worldwide, with restoration of vision especially crucial to the developmental growth period of visually impaired children. So how did Dr. Conan and colleagues make this 3D printed cornea? First, they used the finite element model to create a digital cornea from an actual cornea. Its volume was then used to generate the acrylonitrile butadiene styrene or ABS support structure. Next, they formulated the bioink by combining 8 mg per milliliter methacrylated collagen and 3 weight by volume percent sodium alginate in phosphate buffered saline or PBS slurry, then adding 2 million keratocytes per milliliter, which they cultured from cadaver cornea using standard procedures described in step 2.5. Then, they commenced 3D printing on the ABS support, coated with gel prepared by freeform reversible embedding of suspended hydrogels or fresh method, which compensated for the low viscosity for extrusion at 30 kilopascals from a 200 micrometer nozzle, with the printing following concentric paths to optimize throughput. The fresh gel was removed by aspiration, and the as-printed cornea was cross-linked in situ with calcium chloride and analyzed for biocompatibility via cell-viability assay and fluorescence spectroscopy. Results of the cell viability test show that a significant number of cells survived in the 3D material for 7 days, and this means this research paved the way for possibly solving the cornea shortage problem by introducing 3D printing technology to the fabrication of artificial corneas of same size as a typical cornea, and using live keratocytes in the bioink such that one donor cornea, with all its keratocytes intact, may be a donor to virtually unlimited number of recipients, or at the very least, one donor cornea may now cater to both eyes of a person. So how did the researchers conceptualize this idea? I found one patent application by Dr. Conan, filed in 2010 and published in 2012, in which he claims the idea of cornea growing on collagen substrates to create transplant organs, as studied by an assay for keratocyte survival similar to the one performed in the study. I also traced his early consideration of 3D cornea modeling. So as for my input, I want to use this technology in creating corneal grafts for keratoprosthesis, or the current treatment for repeat traditional cornea transplants, which are more accurately termed as penetrating keratoplasties or PK, where a disc is cut and removed from a diseased cornea to be replaced with a healthy one, with this procedure being repeated due to organ rejections. Rejections often occur either due to first, patients' poor compliance with taking immunosuppressive drugs, or second, a really heightened immune response that cannot be easily resolved by medication. I propose solving the first problem by including immunosuppressive corticosteroid-loaded nanoparticles, here packaged in the familiar core shell structure, into the bioink formulation, facilitating automated controlled drug release, which was shown to have 100% success rate on rats from a 2015 study by Pan et al., who showed that there are no inflammations, as signified by clouding, 9 weeks post-surgery in rats who received the drug nanoparticles. And I plan to solve the second problem by culturing the patient's own keratocytes, and not from a cadaver cornea, making the 3D printed artificial cornea both autologous and antibacterial. I could also combine this with the topic of Ana Briones, where Gallego Perez et al. Can transform skin cells to fibroblasts, which can differentiate into target cells, giving hope to people with severely damaged corneas where no live keratocyte can be extracted. These are the references, and thank you for watching.